Quickly, we invite the next speaker, Dr. Peter Wenzl from GCDT, Global Crop Diversity Trust, who is going to talk on DivSeek, which is an effort to help the scientific community to harness the genetic potential which is logged in the world's gene bank with a lot of germplasm there. To you, Dr. Peter Wenzl.
Thank you very much. Sorry. And thank you very much to the organizers for inviting me here, and a special thanks to Anu, who was able to deal with very complex visa and passport last-minute issues. So I'm lucky that I'm able to attend the conference because of her. This talk is going to be much more a sort of big picture talk, almost data-free, I'm afraid, and reasonably brief, just to tell you a story about a movement that started about 2 years ago, a movement that led to the almost self-organization of a group of like-minded people who assembled around the idea of leveraging all these new technologies and tools that are emerging in the genomics area, but beyond genomics as well, high-throughput germplasm characterization area, essentially, and big data area, to, for the first time, really go into gene banks and systematically characterize and mobilize useful genetic variation for breeding programs. We have seen these kinds of slides in several different iterations, but just to highlight that at the same time as all these new technologies are emerging, the challenges are growing simultaneously as well. So it's luckily it's a coincidence that we have these challenges, but we have also growing abilities to deal with those challenges. The challenge to raise productivity very substantially while keeping the nutritional quality or improving the nutritional quality of our crops in the face of climate change. This study that is being cited by many, study of the FAO, that we need to increase yield by about 60% by 2050, actually explicitly states that the whole study did not take into account the potential effects of climate change. They conclude that it may be possible, but completely disregarding climate change, and this is the big elephant in the room, of course, and we need genetic options to deal with climate change. And also, we are, of course, coming out of a period where we had really underinvestment in agricultural research, which actually coincided with a decrease in worldwide reserves in grains, so it's quite a challenging situation. There are several options to deal with these challenges, and the genetic approach is one of many options, and perhaps, as has been discussed also in this meeting and elsewhere, perhaps it's not the option that will give the most immediate response, but I would argue that working on genetic improvement of crops is a long-term and very broad-based approach to deal with the problem. It's not as context-dependent, probably, as dealing and trying to improve agronomic practices, which are very much context-dependent. But also other areas like policies, for example, access to markets, etc., are very important intervention points. But this meeting really has been, to a large degree, about working on the genetics components, and in particular, the efficiency of accelerating breeding using genomics technologies. And my talk is going to focus on using those technologies to systematically tackle the issue of understanding in a very broad-based manner what is the total available native diversity for different crops that can be used for crop improvement. Now, there are about 7 million accessions worldwide in more than 1,700 gene banks, and these are really very carefully maintained genetic snapshots in time. But until now, as Sarah Hearn, I think, in her talk has pointed out, some of these gene banks really resemble more museums. They are not very broadly and intensely utilized, although there are, of course, exceptions. And they really represent an untapped opportunity to accelerate genetic improvement of crops. And here are these numbers also from Sarah Hearn from CIMMYT, based on an analysis of a good part of the maize germplasm collection at CIMMYT, that show that only 6% of all alleles detected in this GBS survey of the accessions actually have found their way into elite lines, and 94% are only present in land races. So there should be scope to further improve yield, nutritional quality of crops. Also, there will be physiological limits, I'm sure, but I think we are dealing really with a largely untapped resource, and for the first time in history, we now have some of the tools available to deal to investigate this genetic potential in these collections. Before, it was just too big of a bite, too big of a problem to go in and systematically characterize these successions. But today, there's really an increasing emphasis on natural variation in this context, also to deal, not only to deal with productivity constraints, but also with nutritional quality and the sustainability of production worldwide. All these new genotyping and phenotyping technologies that are cheaper and increasingly automated, and particularly this transition from genotyping by assay to genotyping by sequencing is, I think, a very key enabling step for this systematic exploration of genetic resources that has become available now. Because it really enables the digitalization of genetic information in a much more straightforward way. You end up with sequences rather than sizes of bands on a gel, which is much more amenable to the systematic storage and query of the resulting data. And of course, big data approaches have to go hand in hand with this opportunity. So this constellation of circumstances and new technologies has really led to a range of different projects, a convergence of ideas and concepts across a range of different organizations. At IRI, for example, the 3,000 rice genomes project, as you're aware, has been whole genome resequencing, 3,000 accessions, and now is moving towards adding phenotypic data for marker trait association analysis. The Seeds of Discovery project for maize and wheat, Sarah presented the part dealing with maize, is using high-density genome profiling and field trials in combination with pre-breeding efforts to characterize and also sort of proactively mobilize novel genetic variation into breeding programs. There are other efforts such as the Digital Seed Bank project, which is not yet funded but is seeking funding, which is more trying to characterize a limited number of accessions but very deeply across a range of different levels of complexity, essentially going through all the different ranges of omics technologies. The Crop Wild Relatives project, coordinated by the Crop Trust, specifically focuses on mobilizing genetic diversity out of crop wild relatives across a range of about 15 or 16 different species. And the newly funded Bridge project that Niels Stein, I think, mentioned during his talk, is also going in this direction and characterizing the barley collection of IPK by GBS. So there's a convergence of ideas, and the first expression of this convergence of ideas was a meeting coordinated by the Global Crop Diversity Trust about 2 years ago, where a group of, I think we were perhaps 30 to 40 people at that time, of scientists interested in characterizing and mining genetic resources, got together, working on a range of different crops, and we collectively stuck our heads together to see what can we do as a group, as a community. And this meeting led to more thinking in this direction, more discussions, and was followed up by a meeting 1 year later. During this period, there were a range of different discussions going on, and we drafted a white paper as a sort of position statement of what is really possible today and has not been possible just a few years ago. Typically, when in a typical approach several years ago, people would go into genetic resource collections on a trait-by-trait, case-by-case approach, and these new technologies now allow a much more comprehensive approach. So during this whole group of people, we were about, I think we were over 100 people at the time, ranging from gene bank managers, breeders, genotyping experts, informatics experts, etc. The idea, the sort of foundational ideas that went into this white paper are summarized here. Really harness crop diversity for global food security, and to try to do that in a more systematic approach, and also by creating synergies between different crops, because one of the main impetus of this kind of approach is that it is to some degree technology driven, and therefore is bound to create or to work only efficiently if there are standards being put in place. Something that I think Gary has also argued along these lines a little bit. Training and capacity building is likely to be a main area in this initiative, and also by getting together across different crops, the group gains in power for joint advocacy and fundraising of efforts vis-à-vis donors and also political decision makers. There's a white paper, by the way, that can be viewed here, can be downloaded here on the DivSeek website. Now, it was very clear from the beginning that the majority of the people in this group did not want this initiative to be a top-down initiative, a sort of very tightly controlled consortium where a small group of people determines the agenda. It was very clear that the group of people wanted to have this organized as a community-driven sort of bottom-up effort. It was also clear that there were, of course, already several projects that had been initiated. So the idea was to try to link those projects through common areas like information management, databases, IP principles, etc., but not to attempt to sort of dictate the agendas of individual autonomous projects that are crop specific. So the comparison that was made was DivSeek should be like a comb, like the back of the comb connecting individual crop specific activities or efforts. Essentially following the idea that if you want to go fast, go alone, but if you want to go far, go together, this famous African proverb. A small group of people within this large group of people were people who are coming from the social sciences, are working on governance principles, and they have formed a little group that is giving governance advice to help us organize as a group. So really, we believe that the research approaches for different crops, different types of crops, different projects can learn from each other. Crops with different reproductive biologies, for example, ploidy levels, etc. We need common data standards and also legal frameworks. This is something that popped up several times during the discussion to see how we can manage and share the data globally across a wide scale. And also the various technology platforms, many of them have of course been discussed here, GBS platforms, but also high throughput phenotyping platforms, whether it's field-based or glasshouse-based. A big topic, again, has been information management. Information management, both in terms of data storage, querying, visualization, and data analysis tools, and capacity strengthening, of course, as well. I think this project is really good, or this initiative is a good platform for the training of a new generation of scientists that bring together these two different domains that are depicted here in a slightly perhaps funny way. Really, traditionally, breeders and gene bank managers have been dealing with phenotypes, with the physical appearance of plants, and the whole development in the genomics area has added this more informational hidden layer component describing the genetic foundation that gives expression to these phenotypes. And the idea is that the DivSeek initiative will attempt to bring those two domains together by making sure that both phenotypic information and genotypic information is always referred back to a particular, clearly identifiable bag of seeds of an accession in a gene bank. Who will be the clients of this initiative? First and foremost, because of the mission of the initiative to accelerate genetic gains, of course, it will be the demand-driven agricultural research domain where breeders develop new varieties on a global scale to accelerate the genetic gains in these programs. But also there will be a component that feeds into more discovery-driven, more fundamental research to stimulate discoveries that eventually will then generate spillover effects into a crop improvement. And of course, last but by far not least, the gene banks themselves, I think, have much to profit from this new wave of characterization data that will be generated through this initiative. So they can really evolve from being sort of passive warehouses, just providing gene bank accessions to research centers that actively investigate the genetic potential of their holdings. What are some of the challenges and open questions that popped up during all these discussions on the way? One of them, again related to information management, is that it's pretty clear that it will not be possible that there will be a single information management platform that will be applicable and useful and accepted by all partners. So we have to find a different way of operating and working together. Different partners prefer different software platforms, and so the focus will have to be on the glue between the different information management platforms, not so much the databases themselves. And that leads us, to the issue of data standards and tools that enable the interoperability among all these diverse data repositories that will be used by different partners in different regions. But then the question, of course, arises, what is the concrete value proposition for people to stick to particular data standards? Because every single project, of course, can always operate by itself using their own standards. So we have to think, the group as a whole has to think very carefully about what is the added value that I get back by adhering to a particular set of data standards. The challenge of rare alleles, of course, is a big one. Just a few examples here. The grassy stunt virus in rice is a disease that was essentially resolved by finding one resistant gene out of that was identified by screening 6,000 different accessions, very, very low frequency, but this had a very, very big impact. So it's very rare alleles, but with huge impacts. And this is the graph that Sarah already presented before from this very big GWAS analysis in maize in the Seeds of Discovery project, which shows that all the favorable alleles that were detected have a frequency of less than 0.1%. So usually the good stuff is rare, and the question is, how can we leverage genomics technologies or genomics information in combination perhaps with GIS data to identify those rare alleles more efficiently, more effectively. Also, just characterizing gene bank accessions is not enough. We need to mobilize this genetic diversity into elite breeding pools. Whether or not DivSeek itself is going to work in this area is an open question. It may depend on the size of the different crop communities. The bigger crop communities are already doing that in a big way, so it may not be required, and they may want to do that through different means. However, what was clear in the meetings, in the discussions, was that the smaller, the minor crops, I think many people thought that it would be good to provide some support to sort of systematically introgress novel diversity into elite breeding pools. It's very important, really. This step is really very important because new diversity discovered for different traits, or new diversity per se, really needs to be validated in terms of whether these traits, these good traits, are really expressed in elite genetic backgrounds. And that has to be done by crossing. And now in DivSeek, we can take a much more proactive approach rather than a case by case. We can take a broad, diversity-driven approach to introgress novel variation. The big question, of course, is what to do with complex traits, how to introgress traits that have hundreds or thousands of loci contributing to it from exotic genetic background into elite genetic background. And I think some work that is done in the genome byte prediction in the genomic selection area is very relevant, and in silico simulations to see whether, to what degree genomic selection would actually, if it's applied in this context, would actually just restore the elite genotype as opposed to help bring in new genetic variation, I think are very warranted. Perhaps, as has been mentioned in the case of maize and CIMMYT, it is necessary to first assemble or concentrate beneficial small effect alleles just by intercrossing gene bank accessions or land races themselves before taking the next step to move them into elite genetic backgrounds. Now, let me just briefly move to how DivSeek is organizing itself. There are three pieces of governance structure. There's the Partners Assembly, which is essentially one representative of each partner organization coming together to discuss the agenda, the strategy of the initiative. This Partners Assembly sets the strategic direction and elects a chairperson and the steering committee. The steering committee is comprised by the chairperson and 8 partner representatives. And essentially, the steering committee follows the guidelines set forth by the Partners Assembly and implements an annual work plan or defines an annual work plan, which is then operationalized and implemented on a day-to-day basis by the facilitation unit. The facilitation unit is jointly supported by these 4 organizations: the Global Crop Diversity Trust, the CGIAR Consortium Office, the International Treaty for Plant Genetic Resources and for Food and Agriculture, and the Global Plant Council. So essentially, the facilitation unit will be the one that is going to work on a day-to-day basis with partner organizations to implement the work plan. We just had the first Partners Assembly in January in San Diego. There were 69 partner organizations from 30 countries that had previously declared that they're interested to join. Most of them attended the meeting, and during that meeting, the DivSeek Charter was discussed, was fiddled around with, wordsmithed, and approved. It contains this mission statement here to cross-link, support, and add value to individual activities that harness the power of crop diversity for food and nutritional security and societal and economic benefits by enabling breeders and researchers to mobilize genetic variation in order to accelerate crop improvement. So, pretty self-explanatory. The Partners Assembly elected Susan McCouch as the chairperson for the first 2 years of the initiative. And what is happening at this moment, actually between next week and the week after that, is that we are going to elect electronically, remotely, the members of the steering committee. This is what's going to happen next. During this meeting, we also distributed a questionnaire. We did a little survey to get a first feeling of what the top priorities of different partners will be. These were open-ended questions, and we categorized the answers into more than 50 different topics or ideas, which were then counted across all the different responses. And it's very clear that information management is the biggest bottleneck for most people. Half of the answers were related to information management, mostly concerns and desires to create a system of data formats, vocabularies, and standard procedures for evaluation of gene bank accessions, and also data repositories, the availability of data repositories. More respondents in favor of distributed data repositories in line with personal preferences, but all of them highlighted the fact that it's important to have different data repositories being able to talk to each other. A second area that was mentioned several times is just community and networking. People were interested to get together to learn from each other's experiences and to create synergies within across different projects in areas that essentially related to tools and capacity building, and also to take joint action, as I mentioned before, and perhaps get together to jointly seek funding for all these crop-specific projects. Research strategies, there were several discussions, but not very frequently mentioned, perhaps the individual points here, but there was a discussion during the meeting about accession sampling strategies. whether to select a single seed out of a seed bag representing an accession to select a pool of seeds and run an analysis on a pooled DNA sample, or to do SSD to purify lines out of each accessions. These were some of the discussions we had, and other issues were also mentioned, particularly in the context of IP rights and data, and also germplasm sharing. So just to finish off here, over the next 2 weeks, we're going to elect the steering committee, the 8 members of the steering committee, which will then meet very soon and define a work plan for what remains of 2015. And of course, new members are welcome, and you can visit the website here. There's a feedback form where you can sign up for just getting regular updates about what's happening, and also perhaps to become a member. Okay, I leave it here and happy to answer questions. Thank you.
Thanks, Peter, for saving some time as well. Some questions, please.
No, I don't think so.
You got one that works? How's that? That's much better. You highlighted the importance of information management. Now, there are a number of different organizations which are working on this in a crop-specific manner. So you've got the Weed Information System, which is part of the Weed Initiative. You've got the International Rice Informatics Consortium, which must be a part of this because Susan's on the advisory board for that. You've got the Nebraska Bioinformatics Consortium, and I think there are many more. So how are you working with those groups to ensure that there's synergy? Those groups probably have quite a broad remit in terms of managing data and formats and delivering to breeders. You're looking at a broader range of crops, but probably not the breadth. So what sort of mechanism have you got for interacting with those groups to make sure there's no duplication?
Yeah, that's it's an easy question, and there's no universally acceptable and workable answer, I think. I believe it makes sense in those cases to differentiate between the big crops and the minor crops. The big crops are big enough to organize amongst themselves and perhaps come up over time with certain standards. And this, I think, is happening with IRIC, for example, or on the wheat side, as you have mentioned. What we have heard repeatedly is that the smaller crops are looking for something that provides them something to start working with in the sort of big data germplasm characterization domain. And whether there is opportunity to cross-feed from the bigger to the smaller crops, that was one of the points that was discussed. That's a question. I mean, I have certain opinions about that, but it's not up to me to decide. It will be up to the steering committee to take on the vision of the whole group and come up with a first work plan, which will then be fed back to the partner organization. But it's a big topic, and I think it's perhaps an issue that has been with us for too long time, and perhaps now is the time to try to tackle it, because there's a carrot dangling in front of us as well, because now we can do things we could not do just a few years ago. Okay, then we clean up what hasn't worked in the past and we move forward, kind of approach.
Thank you, Peter. I think we can...
DivSeek may actually have a role in helping to coordinate. Can I suggest that DivSeek has got a role in helping coordinate these groups to establish standards going across?
You mean across group? That's the next challenge. I think going across groups will be easier starting with the minor crops. And perhaps that's the nucleus that can then grow in other directions. But I think it's probably very difficult to imagine that very big rice community will get together with a very big wheat community and all agree and we are all happy. It's not going to happen. We know that. But with like legumes, for example, getting together may be more feasible.
Thank you, Peter. We're going to have more discussions later. We need to give some time to organizers for organizing their concluding session. So I believe we move on to the next presentation. Thank you, Peter Wenzl, for a good presentation to you.